Okay, let's start from the place that we left. Right now I'm going to explain about the component of the GIS. Any GIS discipline need these 5 components of the software, hardware, data, people, and method. Each of these components have its rules to establish a GIS. So all these elements are required. Let's start with the hardware. Hardware is we know that it's a very tangible part of the computer. That GIS can be start operate on it. Right now we have a wide range of the hardware from the, let's say, mobile telephone up to the bigger computer, standalone computer, all-in-one computer, laptop, many other computer, even a standalone or network-based configuration. So many GIS software can be run in this variety of the hardware. So any tangible part of the computer called as the hardware. About the software, today we have a different GIS software with a different function for a different need, such as store, analyze, and let's say reporting. This is including from a TCP/IP protocol, which is coming from a network, which is including such as the operating system, for instance, Mac OS, Windows, Android, or Linux. We have a GIS application, open source and commercial one, such as ArcGIS, QGIS, UDIC, and many other programs. And we have other GIS script. This script mainly control the behavior of the system and programming system. Also nowadays we use a Python. You can also integrate the Python inside the GIS and get the benefit of the Python. As I said, we have a 2 main category for software, not only for GIS, for all the program or all the software. One of them is a commercial software, which is you need to purchase the license of them. In GIS, we have ArcGIS, we have a manifold GIS, we have a small world, we have a hexagonal, geospatial, global mapper, map info. These are the most important, let's say, commercial software. So you need to buy and purchase the license of them. And like any other program, also we have an open source, such as UDIC, QGIS, OpenJump, GrassGIS, and Geodata, many other, let's say, open source software. Very briefly, we could say that in terms of advantage and disadvantage, the commercial software, most of the popular software, almost commercial. Even if you imagine the AutoCAD from the Autodesk, the AutoCAD is a commercial one. But if you use only CAD or just CAD, this is open source. Again, one of the advantage or sometimes disadvantage, most of this commercial software can be updated, redeveloped, and reorganized just through the main company or main developer. This commercial program you are just able to get a support just by a individual technical support which is belonging to the same company. Not everyone can support you. The model of this software mainly like a closed box. So the source belongs to the main manufacturer and you cannot change anything inside the program. And a further decision or a strategy also made by a main manufacturer, and the participant or end user have a narrow influence on the strategy of the manufacturer. We have a open source here also, which is have some advantage and disadvantage. The open source, it's open to everyone, anyone, and anyone can do anything that he or she wish. User develop and collaborate inside the forum or over the internet, and even different individual could be contribute to developing those software. They are less complex in terms of the structure, and it is also open, and all the code it's known. You can read and follow the, let's say, structure of it. There are many people can support and provide a technical solution. Even different user of it could be help each other. They support different sort of the standard and different type of the geographical data standard, since they are developed by different individuals. You have an opportunity to integrate with other similar software, and they don't have any development strategy because user decide about their own strategy. This is about the open source software and commercial software, similarity or dissimilarity or advantage and disadvantage of them. If you're coming to the people, GIS technology is of limited value without the people who manage this system. We cannot develop any plan, or we cannot manage the real world problem. So we need a specific people. It could be from data entry people up to end user people. This is like a engineer, analytic, administrator, computer engineering, topological engineering, data processing. We need different people. They need to be work as a system. They need to keep the hand and work every day in this platform to manage the solve of the real world problem. And at the end, a successful GIS operator need a well-designed method. You need to have a method and the model accordingly. Based on this method, you are able to provide a better solution in a short time. So this method could be a data management, human resource management, and financial, of course, management, quality management. We need also time manager as a method, risk management, and we need some other standard. So all these, let's say, work together, all these 5 components or elements to, let's say, create a GIS base for our world. Now, let's again jump back. If you remember, at the very beginning of this lecture, we are talking about the data. We say that It is a qualitative, quantitative, fact, number, picture, word, image, that later we start analyze on it and make information from those data. When we come to the GIS, that first, let's say, definition, it is the general definition of the data. But when we come to the GIS, we have two important data. One of them is a spatial data. You know, a spatial, anything that you can address to it within the, let's say, world. You need to able to address it. It should have a spatial, let's say, location. Imagine this pen. It has a spatial location right now because you are able to address it. You could say that the location of it, it's in X, like let's say X5, Y8, and the height of it, let's say almost 1 meter from the ground. So you are able to address it. Anything like this, you are able to address it. So it means that it is a spatial. But what about the descriptive? Descriptive, it is not a spatial, but it is describe the object or element. So this pen, it's have a spatial data. Now we want to describe it. When we describe it, we say that this is a big pen. This is blue color. It is almost full. Let's say it is a 20 centimeter height or length. It doesn't matter. And we use it for writing. This is all these things called as a descriptive. These are actually non-geographical elements, but we use it to describe the object or element. So we need both of them. When you are describe your site analysis, I'm coming now to the site analysis. Imagine that you are dealing with a site analysis. So you have several buildings. First, you need to address to them because they have a spatial location. One of them in this street, the other one in that street. So you are able to describe the location of them. So they are spatial. After that step, you start to describe those buildings. You will say they are 5 floors, they are, let's say, new building, residential, they are they have 10 flats inside of each building. The color of them is a white, gray, or etc. and etc. So we need both these data, a spatial and descriptive. In a GIS, most of the time we call it descriptive as an attribute or metadata. Okay, it's depend on the program. Sometimes we call it attributes, sometimes we call it metadata. So this is about the data, spatial and descriptive. Now, the GIS system integrate these two in a once. They make both, let's say, spatial and attribute together, since they are separate data, to display and analyze a geographical data. Accordingly, we have a bunch of layers. For instance, definitely you saw a Google Earth. If you open a Google Earth, in the legend part or in the layer part, you will see a different layer. For instance, the road name, location name, boundary name, picture. Sometimes there are some pictures there integrated. So these are the layers. All these provide you information about that area. To have a real good, let's say, GIS, we need to gather all these layers, or let's say all these data, and organize them into these layers. For instance, you are going to gather the data related to the building, different building, and then put it into the building layer. Then you are just going to gather the street, such as accessibility. Imagine one way, two way, a pedestrian way, a roadway, railway, and you gather this and then put them in a, let's say, the street or in the accessibility layer. Likewise, you are going to gather administrative things, such as a governmental, such as let's say any facility related to the administrative things, and then you put it under the specific layer. Infrastructure and utility, power line, water line, and gas line, telephone line, fiber optic line, all these also gather accordingly. So we need to use these layer and in order to reflect our real world to the user. In a very, very, let's say, simple way, we have a main tree layer in our GIS for you as an architecture. In another discipline, maybe we have other, but for you, the main layer are a street layer or accessibility layer, building layer, and vegetation layer. When we gather all this layer, we are able to reflect and represent our world. So this is very important for us. You are also in your analyze, always use this thing. One part you show the vegetation, greenery, tree, and accordingly, in one part you use a building data, building height, a structure, uses, function of it, and in another layer you use a street. Sometimes you are also integrate the climatical things. This is also valid. You are able to integrate the other layer as well. But the main tree layer, these are the main tree layer. This layer, if you remember, I said at the beginning of the course, we have a vector and raster. I'm going to explain what is the vector and what is the raster. We have mainly two, let's say, layer, which you are able to present your feature. One of them is vector, the other one is a raster. Vector is mainly a mathematical base. It is start from a point, then we combine the point together, make a line. If we have a 3 points, we can have a closed boundary and then make a polygon or triangle. But the raster, it's the more typical one, which is an image. It is based and shaped by a pixel. Again, one more time, spatial data describe the location. Where is the location of the element or object, in which place you are able to address it, but the attribute or descriptive data specify or describe what is there, how much of them is there, or in which size is there, and this kind of thing related to the attribution. Okay, so this is about the GIS model, how a GIS model could be shaped. Now, let's go to the main entity representation. You know, since you are architecture, you are working with an entity and a space. Any object in a space represented by a 3 discrete spatial element. The first thing is a point. We don't have any specific definition of the point. Sometimes they said the effect or impact of the pen onto the paper make a point. Okay? But we call it as a simplest element. And in GIS, we are used to identify a specific location. It could be a peak, it could be a node, it could be a one tree location, it could be a one gate, it could be a landmark, used as a landmark, or any things that you can give a point to it. Okay, they are used to identify a single and smallest spatial point. We use this. Okay, this is about the point. About the line, we know that the line have a dimension, not like a point, because in a point we don't have a dimension. The point can be very small, it can be very big. But the lines have dimension because line start to draw from a first point until we finish at the second point. So line could be in an arc space or it can be in a linear base. We use this line to show a continuous point. Okay, imagine that you want to show the road. You need to use a line. A river, or let's say a sewer line, power line, all of these, or telephone line, all of these, or rail, you use a line. It's very simple, you know all of this. And polygon, if you have at least 3 points which are close to each other and closed by line with a boundary, represent as a property or area. We use polygon to show the land parcel, building area, forest, countries, sea, anything that have an area. Anything that have area, we use it polygon. Anything have a length, we use line, and anything have a specific, a smallest unit, we use a point. So during this GIS, if you want to make a map, if you want to make anything, you need to think in that way. If you want to show a tree, you need to just use a point. But if you have a 10 or 100 trees close to each other, such as a forest, in this way you need to use a polygon. And accordingly, if you have a road, or if you have an urban block, especially urban block, if you have an urban block, you need to use a polygon. But if you have a road, rail, power line, river, telephone line, you need to use a line. Now, let's come to the vectorial. What is a vectorial? What is a spatial? What is a raster? As I said, we have two main, let's say, topology to represent the information or layer. One of them is vector, one of them is a raster. As you can see here, the vector can be specified by one point, which include x, y, z, in a mathematical base. If we have a 2 or 3 point, we are able to make a line or arches. All these points should have their own x, y, z. And if we have a boundary of them, like this one, we have a polygon. So this is about the vectorial model. Now, what is the vector advantage and disadvantage? First of all, it is reflect the real situation. You can easily, by looking to this, let's say, image, you could understand this area, let's say this orange area or this green area, start from here and then finish there. Exactly start from here and exactly finish from there. The data structure, as you can see, complex. Why it is complex? Because to draw this, each of these boundary, you need to use a bunch of points, sometimes hundreds, sometimes 200. Then you connect these things, and each of these points have x and y and z. So the draw of it is always complex. Beside each of them, imagine the AutoCAD. I'm giving an example from AutoCAD. In AutoCAD, you have different layers. You know that you have a door layer, furniture layer, wall layer, exterior wall, interior, trees layer. So it is very complex. Each of them have its own layer. You open it, close it, and if you open all of them, you will see all of them. So we need different layer. So again, it is complex structure. Simulation is difficult because these vector data use a mathematical process. Even AutoCAD, you use a mathematical topological structure, which is make the simulation difficult. In AutoCAD, also you have attributes. Maybe you see it or no, but definitely you have attribute. What is your attribute? In AutoCAD, we have limited amount of the attribute. I will give you an example right now. In AutoCAD, you are able to assign line type, line height, and the color. These are the attributes. For instance, you say that exterior wall attribute is a thick, white, continuous color. But if you have a gallery or if you have a mezzanine floor, you use it with a hidden line, maybe with a very light color. So these are the attributes. But in GIS, you can assign thousands of different attributes. This is about the attribute that you can assign. It has a scale accuracy. What is a scale accuracy? You know that in AutoCAD, as much as you zoom, your accuracy is not lost. As much as you zoom, you still have a good quality. But in a picture, after a few steps zoom, you start to lose the quality because pixels start to become big and big. So accuracy here has a scale accuracy, but we are coming to the raster. As you can see here, I put the VS and VS. One of them is vector, the other one is a raster. As you can see, the other one shaped by a pixel, the other one is a mathematical base. And it is good to storing the discrete feature. As you can see, there are clear border and boundary. You are understand which border start from which part and finish where. Okay, this is about the vector. Now let's go to the raster. Same thing for a raster. We use the pixel. In a pixel also we have a row number and column number. We call each of them DN or digital value. Each of pixel have a number. We say that pixel number 1 in a column number 1. Okay, even the color of the pixel have a number. So we are able, for instance, to say to show a point. We just give a color to one of the pixel, then it show a point. This is a raster model. If you want to draw a line, we need to give a continuous amount of the pixel in a line way to draw a line or arc. And for a polygon, same thing. To make a polygon, we need to give a number to the pixel in a way that we draw a polygon. Now, let's come to the raster advantages and disadvantages. First of all, it is a continuous property. It is difficult to say that which part finish where or start when. You cannot easily say. Besides, it is the most common data format. As you can see, if you take a picture, if you go to the scanning, everywhere, it is a very common data format. The data structure are very simple because it is a single layer. You don't have any different layer, all of them in one layer. Easy to perform. You can open it by your telephone, by your computer, everywhere you can easily use it. And also you can perform a different mathematical overlay and operation. Since the pixel is the same size, the simulation also easy. It means that let's give you an example of this in this way. Imagine that if you want to take a picture with a very big pixel size, each pixel like 1A4 or very big. If you take a picture, you will see the differentiation of the color. Very, very easily you understand this is very black, this is very white, or actually it is related to the object that you take a picture of it. So that's why the simulation of it, it's very easy. You understand that, oh, this black, it means that there's a television there. If you just take a picture of the wall, that television over there, and then just capture it with a very big pixel size, not 16 million pixel or megapixel, not with your telephone accuracy. This is a very big, small pixel size. But if we capture a picture with a big size, you will see the distinction. By increasing the pixel size, also data loss. Okay, what does that mean? If your pixel size increase, you are not understand the picture anymore. Okay, also a big space required to capture. Imagine a poster, you make a poster in a Photoshop, maybe 1 to few gigabyte space you need to store, but the drawing that you draw in AutoCAD, maybe a few megabytes you need space to store. And Another thing, it's raster, mainly used for satellite information. It can be easily incorporated, and it is better for a continuous property. As you can see, this is a continuous property which we represent, such as a height, slope, and solar radiation. And this is about this part. And last thing, almost we are coming to the end of the lecture. As I said, for a vector, these are the vector and raster representation. Imagine we want to show in a same size, these are the pixels, as I said, from 0 to 9 row and 0 to 9. We have 10 column and 10 row. For instance, if I want to show a house, a single house, you need to use a point, for instance. But here you use the color of the house. Here I just use the H letter. If you want to show a river, you need to draw a line to show a river. But here you need to give a blue color to the pixel which is follow the river stream. Or if you have a forest, maybe you can represent it by polygon, like this forest and the other forest. But here you are able with a T, for instance, for each of them you can give a green color accordingly. This is the representation of it. And as I said again, each of these data can be have an attribute or descriptive, either a vector or raster. This, let's say, attribute in a raster and a vector coming from these kind of table. They are connect to the vector and raster. They are linked together. Each point or each line or each polygon or each pixel can get its own record from its own table. And at the end, if we want to show a real world, you need to have a raster, you need to have a vector, and you need to have this attribute to describe the information in order to have a real world. This is end of the chapter 1 or end of the, let's say, theoretical framework